though, I'd like to start. Before I begin with the basics of the Docker, I would like to start with a personal experience of mine. Not too long ago, I joined the development team for the npmRD project. It is a web app running on Ruby on Rails, which is a framework I do have some experience with, and I was glad to help out in any way I can. But before I can get working on the npmRD, I would first need to install it and confirm that I can run it locally on my system and see the actual output on my screen. That part was way harder than I thought I would be. The first problem I encountered was that npmRD demands a specific version of the Ruby to run, and unfortunately, there seemed to be no way of easily downloading them from online. I could always build it from the repository instead, but npmRD was not the only Rails app I was working with, so there was a danger that if I changed the Ruby version, that it could throw the rest of the Rails app off the rails, and I would need to start from the scratch again. Another problem was with my development environment, which is the Mac OS. Mac OS being based on Linux makes it very convenient for most development jobs, but its processor is not one-to-one translatable with most of the virtual machine server that operates on Ubuntu, for example. So many of the dependencies for Rails app that would work fine in Ubuntu production or staging server would simply refuse to work with my own machine. I'm sure if anyone ever tried to do a Rails development in the Mac OS, then I'm sure you have some experience trying to download the libv8 and Ruby Racer or Mini Racer through the gem file and being unable to do so. First, you might start searching online, try out some solution that doesn't work, search again with some words changed here and there, and you begin to think if there is any other way of doing this. And the solution I found was the Dockerization. With Dockerfile, I was able to easily create an Ubuntu container that is isolated from my host OS, that installing Ruby directly from the repository archive wouldn't affect any other app on my host system. And dependencies that require Ubuntu-like architecture would work fine inside of the container. And that means I can very easily deploy the changes through the gem file like a Capistrano as well. Ever since npmRD, Docker has been my main platform for developing and deploying any Rails app I'm working with. Getting started with the Docker certainly wasn't easy, but I think I can confidently say that I'm a Docker believer now. So with that story out of the way, let's step back a little and start from the beginning. What is a Docker? Docker is an open source program for management of container. It's been in development since 2010, and it was officially released in 2013. Containers are something similar to virtual machines. We'll get to it later. Just keep that in mind, though. But ever since the Docker was released, it's been the biggest driver in the popularity of containerization, and that is even despite the rival software like the Google's Kubernetes trying to take the Docker's share of pie. Docker, in essence, is a DevOps tool for easy development and deployment of the code base and application housed within the container. And it is available for all of the major operating system, although if you try to use the Docker in the Windows, you might face a little difficulties because you need to use a Windows subsystem for Linux. Basic components of the Docker is remarkably simple. You need a Docker file that translates to read-only Docker image, and that Docker image will be used to create a container that you can read and write to. Docker build commands, Docker file contains all of the dependencies needed for the applications to run and instructions on how to install them. As such, if you have a Docker file that is completely built, then you can be sure that anything inside that container will be able to run without you having to hassle with the system configuration or any other dependencies. Bundling of every components and instruction needed for application into a single container is called process of containerization, which I will be using as a pretty much an interchangeable term with the Dockerization. And this slide is a visual representation of how Docker works. the Docker file is built into a read-only Docker image, and that is executed into a Docker container, which is both read and write. And I'm not saying this because this is a bioinformatics lab, but the basic principle of the Docker is very simple with the very similar to the central dogma of molecular biology. DNA holds all of the instruction needed to build a gene, and that is transcribed into an RNA that is actually used to build a protein and gene. Of course, this is all just a very gross simplification of how both Dockerfile and the central dogma actually works, but both concepts do have a lot of similarities, which I found pretty funny. So I've been going on a lot about containers, so let's talk about them. A container is a lightweight portable package for running an application on user system. Multiple containers can be grouped together as a single service using the Docker Compose command. And once the containers are grouped together through Docker Compose, they can freely communicate with each other, which is very useful if you have a Redis or a database requirement on your Docker container. And container in essence is very similar to VM as a virtual machine, as I mentioned earlier, but it does have a few key differences. A virtual machine is a hardware level virtualization that runs operating system, whereas the container is virtualization of the operating system that runs apps. So you might say that the container is pretty much a virtual machine, but the one layer of the virtualization cut off for simplification. And this diagram shows what I'm talking about. You can see in the virtual machine, every packages need to be bundled together with the guest OS, whereas container doesn't need to do so. It only needs a host OS kernel. And that's actually very useful for me because Mac OS is using the Linux kernel and so is Ubuntu. So I can very easily install Ubuntu on my container and immediately begin development of the code base as if I'm working on the Ubuntu rather than the Mac OS. But you might be asking, why would we be using container instead of the virtual machine if they are both similar? This is something that doesn't have a one true answer to it. There will be a lot of the personal preference involved, and it's something you can ask on one person and get a 10 different answer. But my opinion is that there are three key benefits to using a container. And the first one is that it is lightweight. Because it doesn't need to virtualize an entire hardware to run OS on top of it, it requires less resources to run. Theoretically, you can have hundreds of containers running concurrently. This is obviously a very gross exaggeration, but it is useful if you are if you're working along with maybe a web browser to see a tutorial and Stack Overflow to see how you're supposed to do things. And yeah, and depending on your system, and that might be a little difficult with a virtual machine because virtualization uses up a lot of resources, whereas that is very simple with Docker containers. Another benefit is that containers are isolated environment that is reasonably decoupled from the host environment. As long as we have a Docker container running, we can be sure that it will not be using any component outside of what was specified in the Docker file and Docker image. Having it all compartmentalized is convenient too, because if something goes wrong while development, you can just remove the container altogether, rebuild from the existing image without affecting the host OS and begin development all over again. But it is not completely isolated from the host system either. So you're able to mount some of your host system's file as a volume, which would be shared between the Docker container and your host system. Whereas if you're using a virtual machine, then you would need to use a file transfer between the virtual machine and your host system. So it makes development very simple and easy. And lastly, the container is very portable. Because they are isolated and compartmentalized, you can easily zip them into a file, give it to someone else, give them some instruction on what commands they need to run, and they will be able to run that Docker container and be in the same page as you are in the terms of development. standalone Docker images that does not depend on multi-container is able to be uploaded to the Docker Hub and run immediately as well. So if you have a simple program, then you can just create, you can just compact everything into a single Docker command and have it run on your pipeline or application or whatever. And if you want to, you can have your running Docker container packaged and uploaded into the virtual machine and served for the public as well. This is the example of the Docker container. It's a very simple Docker container that just installs a Python and runs the Hello World program on it. But nevertheless, it shows all of the three benefits of the container I outlined. Because the Docker file is using the host OS kernel, I can simply download the Ubuntu image from the Docker Hub, and the container would be functioning as if it was a Ubuntu machine, basically. And we can also cut out the middleman entirely as well and go for the Python download immediately, and we will be able to run the Python right there and then. And everything needed to run that hello world.python is all packaged into the Docker file and hello.py. And Docker file has all of the instruction and dependencies required. It has instruction to install the Python 3. It has an instruction to symlink the Python 3 into Python. It has an instruction to copy the hello world.py into the Docker image. And finally, run the command, finally showing the hello world on your terminal. And this final bit is the example of the portability. I only needed to run the docker build command and docker run command before I had the terminal yelling out hello world. And theoretically, anyone should be able to do both docker build t hello and docker run hello and have the hello world displayed on your terminal. Of course, this is a very previous example was a very simple example. If you actually do a development, it might get a very, very complex and ugly. It does. And yeah, getting these complex programs to run in the Docker container is where some of the ugliness of the Docker containerization may rear its head. Some of the difficulties involved with the Dockerization is that building the error-free Docker file can be very, very time-consuming. For the complex applications, there might be multiple failure points that can go wrong during the building of the Docker image, and trying to debug everything can be very, very difficult. And in case the gem file is failing, you may need to get into the Rails itself and look through its log as well. It also introduces another layer of the debugging that people may find complex. Another difficulty is that hardware is not abstracted, and because of that, Docker's performance and the Docker performance does depend a little on the system. And this can introduce a platform-specific errors if the platform is not specified during the Docker build step or Docker compose step. Image below shows that a person with a Docker running on M1 MacBook still struggling with the libv8 installation. We can never get away from that, unfortunately. By the way, if you're having a problem with the libv8 installation with your Docker file, you may be able to simply specify the platform into Linux x86, and that may be able to fix. In my case, it does work out very well. So if you have a problem similar to this, give it a shot. Another difficulty is that depending on the host system, the building process for the Docker file can be very, very slow. Docker building step is notoriously slow on the Mac OS. And in some cases, I've seen the Docker building process taking all the way up to an hour. And taking an hour building the Docker images and trying to debug any Docker dependencies is the time you could have spent working on the program itself and fixing bugs or implementing new features. So it is a very fine balancing act between how convenient you want the development to be and how much time you want to spend your time with it. But the biggest problem might be that there may be a security vulnerability if you build your Docker file improperly. One rule of the thumb that you must remember while building a Docker file is that anything you put into the Docker file or Docker Compose, you should expect that anyone with access to the Docker container or Docker image will be able to access and read through. So if you have a Docker file step that copies a SSH key, for example, for GitHub clone, then some user might be able to go through the Docker history and look through the SSH key and maybe use that SSH key for the malicious purpose. So you have to be very careful sharing including any kind of sensitive information on the Docker file. And another security vulnerability is that many of the Docker file may involve the third-party Docker images from the Docker Hub. From the simple example I've shown with the hello world.py, I used the Ubuntu 20.04 official images. It is good idea to not reinvent the wheel whenever possible, but you have to make sure that the image you're downloading is coming from the official and verified uploader, because if you download any random images, then it might contain a malicious code that can run havoc on your operating system. Apparently there was a malicious images that run crypto mining on your computer, so that is not something I want to deal with. Looking back into the central dogma of the molecular biology, it would be like having a DNA with a prophage region embedded into it and having it proliferate all over your body, and that's not really usually not something you want. So as a summary, Docker is a tool for managing and building and sharing containers. Containers are portable, lightweight, and isolated, which makes it a very powerful tool for DevOps in a team setting. It just cuts down the instances of it worked on my machine, so why doesn't it work on yours drastically? But improperly built Docker container may contain serious security flaws, or it can make it inefficient to work with. So you have to be very careful in how you approach the Docker building and how you approach the Docker deployment. By all means, I'm not the best authority when it comes to the Docker, but I have a lot of experiences working with the Docker images, building, deploying, and deploying and doing development with it. So if you have any questions, I would be very glad to answer. Thank you.